Encoders are devices that are specifically designed to convert information into electronic signals in terms of digital and sequential devices. Now if we look at an encoder for a simple keypad, consider the following. We've got a whole bunch of pull-up resistors, one, 2, 3, 4, 5, 6, 7, 8, 9, and each one of these are connected onto my keypad as a button. At the bottom here we've got 0 volts connected, that's number 2, and that's my positive voltage supply. Now each of these switches will then connect in some way to one of 4 NAND gates. Okay, so looking at all of these switches, I'm just going to, in order to save data and save time, I'm just going to identify these switches as 3, 4, 5, 6, 7, 8, 9. It's only 9 switches. Now, when we're looking at these switches, we need to remember that these are all going to connect in some way to a driver IC, to a 3. Now, this NAND gate represents my least significant bit, and this NAND gate represents my most significant bit. Now, if we look at the concept of the least and the most significant bit, this is what we look at, and we consider the use of the 2421 code. Now if we look at a binary number, for example 1001, we can see that, the 8421. If we look at this number, we can see it's 1 plus 8. That gives me a 9. So that means that my most significant bit, which is this one, must then connect to there, and my least significant bit must also connect to that line. And in doing so, I can then convert all this information into something useful. Counters and adders and data input units can use at a later stage. Now this section of my diagram, this is my binary coded decimal encoder, and I got this from the data sheet of the 4028 or similar IC, and that's my encoder. Its function is to convert all this information, depending on which button is pushed, into a binary code, which we can then use to calculate with at a later stage. The decoder circuitry is a lot more complex, but the bottom line for the decoder works as follows. It has to take information, which we got here from my encoder, A0, A1, A2 and A3, which are my inputs, and it needs to convert that into 7 outputs, which we will then use to connect to my 7-segment display unit. So the decoder decodes or translates information so that another device is able to present it back to the user. Now, a popular IC used for the decoder is the 4511 IC, and basically what it does is it says, if these are my inputs, 1, 2, 4, 8 code, and these are my outputs, that each represents one of the outputs that is presented on a 7-segment display. If we look at zeros, remember that's A, B, C, D, E, F and G. So in this case, all my outputs must be 1 except for the G, and that will then represent my 0 on the output. Same applies for all the additional inputs. Let's quickly just draw them. 1, 1, 1, 1, 0, 1, 1, 1, 0, 0, 1, 1. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So my 1 is going to be represented by those two, which is B and C, and the rest are all zeros. 2's is top, down, horizontal, down, right. So that'll be A, B, G, E and D, with C and F 0. 3, they are all going to be on except for F and E. And the process continues down to the bottom.